Hello everyone, today I will introduce my final project. My project is building a classification for microstructure images based on texture vector representation. First of all, let me show the workflow of my entire project. Here, a pre-trained convolution neural network VGG16 is introduced to work as a feature extractor. Our training set, which contains scanning electron graphs, will retrain this neural network. That is, by using the scheme of transferring learning, we will learn a good model which can extract the macrostructures from the images of our training set. Next, one convolution hidden layer has been selected as the texture vector representation, which is also the input features of the final classifier SVM. In order to deal with the multiple labels problem, 1-verse-1 voting system is introduced, which includes 6 pairwise classifiers since we have 4 different labels. Here is the data set. 17% of the images will consist of the training set. The remaining will be the test set. Generally speaking, the convolution neural network should be pre-trained by Keras library and our training set. Then, 6 pairwise classifiers should be trained by the texture vector from the selected hidden layer. When a new image to be classified, it should be fed into the neural network to get the texture vector. Then, feed this texture vector to 1-verse-1 voting system to get the final prediction. The hidden layer is selected according to 10-fold cross-validation. In this study, the error rate of the deepest hidden layer is smallest, which means the later hidden layer are more likely to capture the local structure information. The reason for this has been illustrated in the report. In the evaluation section, we test the performance of the whole system, which represented by 1-verse-1 voting classifier. Also, pairwise classifiers has been evaluated by the mean text error rate. The whole classifier worked well for the images with single macrostructure. However, it failed to classify the images with mixed macrostructures. Similarly, all pairwise classifiers perform well except those designed for the images with mixed characteristics. The zero error rate does not mean this model is overfitting, since it is test error rate. There are some lessons I have learned from this project. The size of training set is very important, especially for the complex model like neural network. Small size of training set may prove difficult and potentially provide poor results. Different initialization of parameters not only decide the training time, but may also lead to completely diverse models because of the existence of local optimal values. Thus, all these parameters should be modified repeatedly in the process of initialization. When a new image needs to be classified, there are only 3 classifiers are effective, which means the remaining 3 classifiers will definitely make the wrong decision. And the error caused by this design will finally affect the evaluation of this whole model. So, 1-verse-all scheme can be tried to fix this drawback. This system works well as the expectation, since the accuracy of classifier is almost over 90%. There is no network need to be retrained once VGG16 and the pairwise classifiers has been trained. Even though training a deep neural network is time-consuming, the texture vector for a new image will be obtained in a second once VGG16 is pre-trained, which means it can be applied in a real world. Thanks for listening to me.